would encourage you to be working on the problems I passed out. But 95% of people miss number 6. So let's see what happens. So number 6 said we gave you some data about Social Security. 10 a.m. a survey was conducted. 425 people out of a random sample of 1,026 stated they wanted to make major changes to Social Security. Construct and interpret 95% confidence interval. Some people didn't do the conditions. It's not clear to me why. Most people, though, seem to get part A quite nicely. They wrote the name, 1, sample, Z, interval. Some people put test here. We're not doing a test. We're just getting an interval. Then the conditions, of course, random. I won't belabor the point here. Independent, population, 10 times sample. And of course, NP greater than 10, the number of successes bigger than 10. N times 1 minus P bigger than 10, number of failures. All those conditions were met. Then we just needed to go confidence interval, P hat plus or minus Z star times square root of P 1 minus P over N. Most people did this, filled out their answers correctly, and they got the following as their interval. Most people were able to get, excuse me one sec, let me tell you what the majority of you all were able to get, which was good. Unfortunately, our success largely ended there. The confidence interval 0.38409 and 0.44437. Interpreting was not bad. We are 95% confident that the true proportion of people who want to change Social Security is between 38.4% and 44.4%. That was good. Then we got to B, and wheels began to come off. 95% confidence. Another way of saying 95% confidence level. That means 95% of the samples will contain the true proportion of people who want to change Social Security within the confidence interval. I did not expect A and B to be problematic. C was hard. C was hard in some senses and easy in other senses because there were 4 possible ways of attacking the problem, all of which would have given you the right answer. What are the ways you could have... Okay, so for that, are there any questions on A and B? Social Security. Are there any questions on A or B? No. All right. Now, here's where things got interesting on C. So there were 4 people, I think 3 or 4 people got it right. One person used a chi-squared test for association. That was totally fine because you had 2 categorical variables. You had time, and you had change Social Security or not. And they made a matrix that looked like this. This said 10 a.m., a.m., 10 p.m. This is how I thought like most people would do it. And then we have yeses and we have nos. So how many people said yes at 10 a.m., 425? How many people say yes here? 82. And then how many said no? Well, of course, you could just sort of, what's the word I want to use here? Subtract. And get 601 here. And get 56. And then they just ran a chi-squared test of association. They got the right answer. Totally fine. They wrote the hypothesis, all the conditions, etc. Giselle decided to do a chi-squared test for homogeneity. Totally fine. She said comparing 10 a.m. and 12 a.m. responses. That was fine. Victoria decided to do a two-sample Z proportion interval and noticed that 0 was not in the interval and then made her decision. You could also have done a two-sample Z test for the difference. Somebody tried to do that, didn't really finish it perfectly. Anyways, there's infinite ways of solving this problem. All you had to say was compare what happens at 10 a.m. to what happens at 10 p.m. I think the easiest way to do it is with a chi-squared test for association. That's what I expect people to do, or a two-sample Z interval. Whichever way you choose is fine. On the exam, you'll have a problem very similar to this. We'll ask you to make one of those choices. I would suggest doing it in the following way. You may want to note this down as you will need it on Tuesday. I would suggest doing a two-sample Z interval and then just sort of working through this. Remember, the math step is confidence interval equals p hat 1 minus p hat 2 plus or minus, try not to look on the board, Nathan, Z star times the standard deviation. Nathan, I appreciate the honesty. I'll take you far in life. Okay. Remember, folks, this is straight on the calculator. P hat 1 minus P hat 2 plus or minus Z star times the standard deviation. Of course, standard deviation is given to you on the formula sheet, right here. It's just right here. So there's no need to try to memorize it. It's right there. PQ over N plus PQ over N. And then just see if 0 is in the interval. If 0 is in the interval, not significant. 0 is not in the interval, significant. Those of you who like to do it with chi-squared, that's fine. You can do it like that on Tuesday. Eddie. Oh yeah, if 0 is in the interval, then we would say that the results are not significant. In other words, they're not significantly different. If 0 is not in the interval, we would say yes, they are significantly different. And you could just use like a 95% confidence level on a problem like this. Okay, are there questions on that? Okay, so having said that, let me disseminate a new review sheet. 6 problems on here. You all obviously don't need to finish all this. We can stop this. You should try to do some, so you don't finish all this.